All right, so we got folded tanks, 3 folded tanks. Those folded tanks are running drilled hose lays on the roof. There's one running up there. There's one that runs up and runs the ridge top of that building. Okay, and now I'm talking configuration and how I'd set this up. So here's my Mark III, 2-inch suction. It's just my preference. 1.5 is fine. Okay, and then I got a pigtail. It goes to check and bleeder. Now, check and bleeder, you still want it in there. It's a check. Is the main thing it's doing. Is the check piece, because this stuff is going all up high up to rooftops. So when it goes up to rooftops, it's going to have head pressure coming back down, and that check will keep it from, you know, coming back here and making it hard to start your pump or leaking through. So we want this one to be opened, and that feeds our sprinklers. In fact, we need to put a piece of the polka dot tape on that one. We can do it here in a minute. And this other one, straps getting in the way. Other one's flagged in blue. That blue goes back to the tank all the time. That's our supply. In this case, it's our recirc, but we're recirculating off the 1.5 and take it all the way down to the valve. So when you walk up to the valve and you look at the valve, you go, okay, that runs the sprinkler system, right? The blue goes back to the tank. So either supply or recirc is the blue going back to the tank. And then I come up here and I have this configuration. So going out that way, off that Y, goes to one rooftop. Going out this way goes to another rooftop. They're both open at the same time. And why in the world do we have Siamese in there? Anybody want to answer that question?
Is this for class or what?
Yeah, more or less. For class. Why do I put the Siamese in there? 2 reasons. Because remember how I said that we're going to have one tank or one pump running the sprinkler system and one pump running the hose lay, and we're going to have another pump. That's our spare pump. So the spare pump will come out and it'll Y off immediately, and it'll run into your Siamese here and into a Siamese on that side, so that if one of your pumps goes down, you have a redundancy in the system. You fire up that other pump, shut down the first pump that was, you know, failing, and your downtime is minimized. So that's the redundancy that minimizes your downtime. When your exposure, or when your resource that's being exposed to the hazard is of high value, you want to put in redundancies just to keep the system running. The sprinklers are a system that runs independently, so you just need to make sure they keep going. And the places where we fall down on are things like water. We either run out of water, we run out of fuel, that's a big one, and we have a mechanical issue. Those are the ones that we can plan for. Mechanical issue, you have another pump. It's set up and ready to go, not sitting there waiting to get put in, but ready to go. Boom, the whole system works. Supply, that's why we have 3 tanks. One tank's our main feeder supply. This one, both pumps out of it. And the yellow one and the pumpkin, both are fed by the hydrant system, which is non-electric, it's all gravity fed. So we can continue to feed those, and those can continue to feed this, and we can make adjustments as needed. If we have to, if we're using too much water, we can move a pump over to run out of one of these other tanks with minimal interruption. Right?
Correct.
Okay.
Why are we back mixing? I heard, can't you have it take the pump that way?
No. All right, so quick recap. We're going to batch mix.
Yeah.
We're only going to batch mix the videos,
No.
and that's why I'm recapping.
Yeah.
Because I'm recording this.
Oh.
It's okay. I still want you to ask questions. Questions are good. Okay, we're going to batch mix. We're only going to batch mix in this tank because this is the feed tank. This is the tank that all of our hoses or all of our pumps are plugged into, and they're going to pump out of this. Okay, these are our reserve supply tanks. Those tanks feed this one, And we don't want to batch mix in them because we can meter it better in a single tank than we can in the other ones. And if we leave the other ones clear, it makes cleanup easier. And it allows us to take the water out of that and fill an engine if need be. That's totally contingency and not really part of the primary plan. But if we had to do it, we could do that. It'd be best not to put foamy water in your fire engine. It makes a mess. Okay, I think Oni said, won't the mixed solution in this tank, since we're doing the siphon, won't that siphon back into the other tank? The answer is no, not when we're running it, because this is always going to be getting drawn on. It's always going to be low, and those tanks should be kept topped off, so they should always be feeding into this tank. At some point, you'll have to re-batch mix to get more foam into this system, and that's fine. But at least initially, you'll be, the single batch mix to get us going, and then those tanks should not get any foam in. Now, when we're going to test run this, and once we're done test running it, we'll break the siphons if we even hook them up. That way, we don't get some of that to flow back into it. What was your question, Rat?
How come you're batch mixing it and not putting in like an inline foam system?
Because I forgot to bring my inline foam system for a hose lay. I don't have one in my back pocket. The answer is there really isn't one. There's not a good one out there. There's a handful of different ways. Some of the Robwin systems can actually be used independently. I think Scotty's got a system. You can put a puck proportioner in line, and they do work, sort of, but that's not really what they were designed to do. There aren't a lot of systems that are designed to go into a portable pump setup and work. The ones that are those, the ones you'll see on some of the state rigs have them, the really super basic round the pump proportioner system. We don't have any of those anymore. We've done away with it. We have really highly complex foam pros and aqueous and Darley super fast foam, I think is what it's called. Those are all much more complex than plugging into a portable pump system. Do we have one? Yeah, there's a HydroFlow HF100 Robwin system sitting in the shop there. We could use it. But they're also problematic. There's a reason we stopped using them on engines. Well, number one, they were never designed to be on an engine, but they also have a lot of failure points. So rather than that, we'll just batch mix. We're not going to hurt anything. I remember the other part of your question. Can't pump and foam cause cavitation? No.
Well, cavitation or...
Cavitation's, first of all, cavitation isn't sucking air. Cavitation is pumping more water than you're bringing in. Okay. It's a physics thing where you're not getting enough supply to meet your demand. Your suction becomes so low that the suction side of the pump, the pressure becomes so low that you are effectively boiling water at whatever the temp is out here, 80 degrees. That's to put it really simple. It's actually a really complicated, it's not that complicated. It's kind of a funky, weird physics thing, cavitation. And we use cavitation to describe any possible mess ups in the system, like an air leak. I got an air leak, oh God, it's cavitation. Well, okay, it's not really that inaccurate of a statement, but it's not really correct either. When I batch mix with this, and I'm pumping this water, I'm pumping a foam solution. Okay, if there's bubbles on top, I'm not pumping the bubbles. The bubbles aren't what's getting pulled through the hose, it's the water. It's the solution with the foam concentrate in it. So can you pump foam concentrate? Yeah, or not concentrate, but foam solution? Yeah, absolutely. That's how those independent systems, like around the pump and systems that you'd be able to put in line work, they commonly will pump the foam solution through the pump itself. So, that makes sense? Okay. We're not going to be sucking bubbles. And at the point that we're sucking bubbles, we're using Mark IIIs, they're going to overspeed and shut themselves off anyway. Cool? Any other questions? Everybody knows what we're doing and why? Sort of? We're just testing.
Yeah.
All right, so how do I batch mix in a 1,500 gallon tank? 15?
Or the whole thing.
Dump it in.
Pour the whole thing in there, right and wrong.
Just like you
So this whole time
Two
dealing
glugs?
guy knew foam really well. He had a really technical way to put it. It's two glugs and a gloosh to a tank. Right? So you tip the thing up, it goes glug, glug, and then on the third glug you kind of pick it up and get a little splash.
Like
That's a pretty damn good way to meter it. It actually works really well.
2 glugs
So let's
and
give
a
it a shot.
splash.
Want to give it 2 glugs and a gloosh there?
Gloosh. A gloosh, not a splash. Copy.
Is a gloosh bigger than a splash?
It is. Slightly.
Whoa!
Don't
watch your other one.
One.
That was a lot of.
That was a
Those
glug.
were like a
Those
slippery
are splashes.
I'd put a little bit more in. All right, I think that was like the perfect 2 glugs and a gloosh. So we've definitely overdone it, but that's okay. You know, we wanted to get some bubbles in it. And when we start running the system and moving foam, once we start bringing more fresh water into the system, at some point we'll have to top that off. And usually you top it off with a quick tip. That's it. That's all it takes. It doesn't take a lot. Foam will last a long time. 5 gallons of foam in your Type 6 engine at 1%, you can do the math. It's a lot. At 0.1% is a lot. So you can go a long ways. It's several tanks. So, what?
About 5 minutes and the tank of foam is gone.
I copy. All right, we good? I'm good.